Traditional methods of installing underground utilities can be extremely disruptive to the above-ground world. Ditch Witch product development is always striving to find new ways. Our trenchless technology allows you to operate underground without disturbing the above-ground world. Let's take a look now at how Ditch Witch technology makes this whole process work. The first step in the process is to carefully plan the bore. To begin, all existing underground utilities are located by their respective owners. This is normally accomplished by simply contacting a one-call service for the local area. The next step in the process is for the crew supervisor to walk the site. During this, the supervisor will inspect location markings, determine the soil type, determine an entry and exit point, and formulate a path around all obstacles. The supervisor will then mark a proposed path with white paint. This intermediate inspection serves as a double check to ensure that the site looks reasonable and logical. The Ditch Witch track management system allows the crew to accurately plan and document a bore. Now that we know where we wish to bore, let's take a look at some of the technology that allows us to accurately execute a planned bore. The first thing we need to be able to do is to steer the drill head underground. The patented Ditch Witch slant nose technology provides a mechanism that allows the operator to accurately control the direction of the drill string. As the name implies, a slant nose drill head contains a cutting surface, which is offset at an angle with respect to the rest of the drill head. If the operator wishes to proceed straight ahead, equal amounts of thrust and rotation are applied to the drill head. The rotation of the drill head causes the drill head to resemble a conical cutting surface, which tends to cause the bit to go straight ahead. If the operator wishes to change direction, the drill head is rotated in such a way that the slant points in the direction of the desired change. The drill head is then thrust forward without rotation, thus causing the entire drill string to follow the new direction. Once the desired direction change is achieved, rotation is applied to again continue in a straight path. Now that we have seen the technology that allows us to steer underground, let's look at the actual procedure that is used to accomplish this. The first step is to set up the jet track unit. Notice how gentle the rubber tracks are on turf. Before any activity begins, the safety of the site is ensured. Crew members must always wear approved safety equipment, and they are taught very specific procedures that they must follow during the system setup and throughout the bore. Generally, the operator begins by testing the electrical strike detection system. The entire boring system is next isolated from spectators and other crew members with cones and barrier tape. After the site is completely secured, a crewman installs the voltage limiter stake for the electrical strike system. The crewman then exits the secured area. Only then is it permissible for underground activity to commence, and the operator will now stake down and ground the unit. Before the actual bore begins, the crew will perform a final survey. This survey includes noting grades, calibrating the tracker, and exposing any underground utilities that the bore will pass. The crew will also note the soil type, select a bit, and a drilling fluid mixture. The drilling fluid is composed entirely of environmentally friendly components. The fluid mixture is determined by soil conditions and is used for a number of purposes. We have seen some of the pieces that make up a guided horizontal boring system. It is now time to take a look at what happens during an actual bore. The jet track boring system provides a high degree of automation to assist the operator during a bore. Operations such as pipe makeup and breakout, and even feeding the pipe are accomplished with the lowest level possible of operator effort. Jet track units are the highest horsepower units in their class, and are designed to focus their power toward putting the most amount of pipe in the ground in the least amount of time. We know that steering is accomplished by pointing the slant-nosed drill head in the direction that we wish to bore. This poses the question of how do we find out where the drill head is, and in what direction it is pointing while it is underground. Each drill head contains a beacon, which transmits a signal that is used by the locator to determine the depth, inclination, right-left heading, and the tool face orientation. This information is displayed to the locator operator on an LCD contained on the locator. This information is also relayed to the remote display on the jet track, so that its operator can see similar information. The locator operator calls the shots for the bore, because that is the only person who can see obstacle marks and the lay of the land. So, it is the locator operator's job to ensure that the board proceeds according to plan. Once the locator operator is satisfied with the location of the drill head, they will mark the location of the drill head and tell the jet track operator to log the pipe into the track management system software. Right and left corrections in compound steers are done in a similar fashion. Now that we have reached the end of our bore, it is time to backream and pull back our product pipe. The slant nose drill head is replaced by a backreaming tool like the Ditch Witch beaver tail backreamer. The purpose of the backreaming tool is to enlarge the borehole and clear a path for the product pipe. The product pipe is attached to a swivel following the backreamer. The jet track pipe handling system also assists during the backream phase. The system will assist the operator in removing the pipe from the ground and inserting it back into the pipe rack. Now, we have completed our bore and pulled back our product pipe. The utility product is now in the ground with very little restoration required. At this point, all that really needs to be done is cleanup. The use of a drilling solution during the horizontal bore has provided us with a critical benefit. After we have removed our drill pipe, the fluid and soil mixture forms a solid mass around the product pipe as it dries, leaving no voids. Studies have shown that this provides a far superior final result than compacted earth. A horizontal boring system is just that. It is a complete and finely tuned system. Each component is critical and must be matched to ensure the proper functioning of the entire system. Because of this, the people that bring you Ditch Witch equipment manufacture each component of the system to the highest standards in the industry. We hold the patent on slant nose steering technology and manufacture these drills in a number of different configurations. The beacon within the drill head, as well as the tracker and remote display that use it, are all designed and manufactured by our sub-site division. We manufacture our own patented drill pipe in order to produce pipe that is perfectly matched to the horizontal boring process. The jet track units themselves are the strongest and most highly automated units in the industry. We make the complete system, and we back it with the finest independently owned dealer organization in the world. Our dealers exist to help you, and if you have any questions, your local dealer is ready to become a valued member of your team and to help you find new ways.
The purpose of this animation is to illustrate the basic process of horizontal boring for proper operating and safety procedures. Please refer to your operator's manual.